Hi, my name is Sebastian Piotrowski. You can contact me via email sebastian.piotrowski@gmail.com. You can also visit my blog blog.katio.pl. Today I'll be talking about unit testing. I will be talking about bright and dark side of the power standing behind the unit tests. The aim of this presentation is to make you convinced that you need some tests in your solutions. I'll be talking about what is the unit test, when to write it, how to write it, so I will mention some best practices about writing unit tests, and I will also present you some technique that allows you to write unit tests efficiently. So let's start. First of all, let's think about a question: why do you need unit tests? Have you been thinking about it before? When I've asked this question to my colleagues, I've been a bit surprised with the answers. The most common and the most obvious one is to finding some bugs in our applications. Of course, this is a nature of the testing, to find some bugs. The other answers were to have statistics and have statistics at the very high level, like for example the code coverage near the 100% in our solutions. So our solution is great because we've got some unit tests and we've got a lot of them. The other reason is to test as a documentation. So instead of writing a docs, we are creating a unit test and we've got all the code documented via unit tests. And there were some other answers. Some of them were to just running away from this topic and not giving me a straight answer. Why do I need unit tests? So let's start with the common definition of unit testing. Unit test, a piece of code that invokes a unit of work and checks one specific end result of that unit of work. If the assumptions on the end result turn out to be wrong, the unit test has failed, and the unit test is then marked as red. If the unit test pass, then it is marked as green. I've taken this definition from the great book about unit testing, The Art of Unit Testing, written by Roy Osherow. Roy is a well-known person in the world of unit testing. If you would like to see some examples, then take this book and you can find there a lot of examples in .NET. However, you can easily apply the examples also to and translate these examples to other languages. So when we know the definition, then let's think about where to put the unit testing into the phase of lifetime of your application. And here I've put it 3 boxes. First of all, the design development phase, then the verification, bug fixing, and the last one is the production deployment. So let's think about where to put the unit testing. To production deployment? No, it's a bit late to run the unit tests and think about testing when we are already on production. Then the verification, bug fixing. Closer, but not perfect. The best place to run the unit testing and think about unit testing is the development design. To be more precisely in here, the design. We should think about unit testing, and the unit tests can help us a lot when we are thinking about our application and we are thinking about our implementation. So let's have a look at some best practices while writing unit testing. Now, when we've got when we know the definition and when we know when to write the unit tests, in what phase of our application, then let's have a look how to write tests. First of all, the clarity. So the readability of the code on the same level as the rest of the application. The common mistake is to thinking that unit testing project is not something that will be run on production. It is not valuable from the business point of view. So I won't be looking at the code coverage at some elegant level of the code. This is not true. Let's think about this project and keep this project on the same quality level as the rest of our projects in solutions. Then the individuality. So let's create test class per class we want to test. Create tests per method we want to test. Do not test several methods in one test. Then the naming convention. So there is nothing like naming convention in the case of unit testing. Names should be easy to understand by all developers, and I advise you to just have a meeting with all the developers that will be engaged in the project and think about some naming convention that will be understandable by all of them. Then we've got the code coverage. 100% code coverage doesn't mean 100% tested code. There is no need to test some third-party functions, some built-in .NET framework functions that we are using in our application or that are standing most of our methods. Be focused only on the functionality that you really think that is worth to be tested. And the isolation. Do not touch the file system, database, and so on. Do not count on the environments that can make the test working in different way. To isolate some environment variables or file system or database, we can use mocking frameworks, and in here I've put several of them: the TypeMock, the RhinoMock, Mockito, or Microsoft Fakes. It is up to you which one will you choose, but do not try to do not touch the system parts while running your tests, because the system parts can be changed. Then the assertions. Avoid redundant assertions. The test should be straightforward, easy to understand, and easy to verify if the test is passed or failed. Then the ordering. So try once a time, try to run your tests in some different ordering. So change the ordering of while running your tests and verify that the tests are passing. Then the time. The time is quite important in the case, especially in the case if we want to run our tests locally. The short time of execution will make you more happy, and probably you will run your tests more frequently than if the execution will take you a lot of time and you will be only watching looking at your on your monitor. So keep the logic straightforward. Run only the tests that you are being interested in. You can group the tests, so try to organize them in some best way. Then the automation. The unit testing can be easily set it up as a part of continuous integration process. In here I've put it as screen from TeamCity. You can easily add a step to unit test to run the unit tests in your solution right after the building of your solution. You can also try to play with the MS Build scripts to automate in some way the running of tests after the building, for example. And choose the test runner you like the best. In here I've put it several test runners, the NUnit, the ReSharper, and the built-in Visual Studio Test Explorer. Choose the one you like the best. All of them should give you the same results. So now when we've got the knowledge about the basic knowledge about unit testing and got some information how to write the unit test in best way, we can have a look also at some technique that can make the writing of unit testing more efficiently. It is called the test-driven development. So let's have a look at this, how the test-driven development is working. In here I've put it a very simple steps to creating and building our project. So first of all, if we want to modify our project, if we want to add some new functionality, we are adding a test and running it. If the test is passing, then we can add another test and running it again. And if the test is failed, then we have to do some changes in our code. To change the existing one, add some more code to cover the new requirements. Then we are running our tests, and if the tests are failed, then we are going back to changes in our code and running the tests again. And when the tests are passed, then we can go back to beginning and start adding new tests to cover new functionality. How to remember this in best way and easier way? The RGR, red, means that you are adding your tests for the logic you don't have, so the tests, and running the tests, so the tests are red. Then you are in the green phase, so you've added a test, you've added a code needed to make the tests working and make the tests to be green, and after that you can refactor. So after refactoring, you can try to once more run your tests and see if everything is working. If not, then you are starting the cycle again. So the red, green, refactor, the three words, or in other words, make it green, then make it clean. Very simple statements that are quite useful in the world of test-driven development. So the summary of this technique. First of all, you've got the code logic validation, and then you are focused on the interfaces design before development. Then you are developing a small part of application at one time. Your code is modular, so easy to be reused, easy to be excluded from your solution and reused in somewhere else. Then you've got the unit tests ready when the development is ready, so you don't have to write your tests to make your statistics better after the development, but you've got everything at once. If you've got any questions, please contact me via email sebastian.piotrowski@gmail.com or visit my blog blog.katio.pl. Thanks for watching and see you again.